Page 1 of your review packet from Monday, October 15th. This is to help you figure out the solutions to that review packet we did on Monday, and also to help you study for your test on Wednesday, October 17th. So let's get started. Number 1 says, determine the area of the sector to the nearest square centimeter. It's the nearest tenth of a square centimeter of a circle that has a diameter of 20 centimeters and a central angle of 5 pi over 12. And it tells us that we want to use this formula, A equals 1/2 r squared theta. Based on this information, I'm trying to find A, and I need to find R. I need to know R in order to find A. And I know that R is my radius, which is half of my diameter. And if that is true, and my diameter is 20 centimeters, my radius is half of that, which is 10 centimeters. Theta is the angular displacement or the distance that I traveled around my circle. And you want that in radians. If we look at this right here, 5 pi over 12 is already in radians. How do I know that? This pi right here tells me it's already in radians, so I don't need to change it to radians. And I know that it is my angular displacement because it tells me that's my central angle. So I already have theta, 5 pi over 12. All I need to do now is substitute into my formula. A equals 1/2 r squared, my r is 10 centimeters, times my theta, 5 pi over 12. And you can do this out and figure out the exact value, but I'm going to tell you now, you have a calculator, save yourself time and just put it directly into your calculator. So I'm going to type it in. 1/2 times 10 centimeters squared times 5, and to get to your pi button, you press the second and this little caret right here, right below clear. So second caret, that gives you your pi, divided by 12, and hit enter, and we get 65.450 centimeters squared. And it also told us that we want to round to the nearest tenth of a square centimeter. So I'm going to round that to 65.4 centimeters square. And that's how you solve number 1. Number 2. If cosine of theta equals -3 over 5, and theta is between pi over 2 and pi, find the other 5 trig functions for that angle. Okay, now the first question I always ask you is, where is it? Well, this right here tells me where I am. Theta is my where is it answer. So between pi over 2 and pi, if I know that pi over 2 is the positive y-axis, and pi is the negative x-axis, I know it has to be somewhere in the second quadrant. So I know it's in quadrant 2. I also know that cosine of theta in general equals x over r. Okay, so looking at the fact that it's in quadrant 2, and that cosine is x over r, I know in quadrant 2, x is negative, but y is positive. If I'm trying to find all of the values, cosine is -3 over 5, and since x is negative, I'm going to take this negative and assign it to the top value, 3. And of course, your r, your radius, is always positive. So that tells me that x is -3. R is 5, and I'm missing my y value. How do I find y? I'm going to use the Pythagorean theorem. x squared plus y squared equals r squared. Or in geometry, we say a squared plus b squared equals c squared. I know my x is -3. Remember to use parentheses, otherwise we may come up with an error. I don't know y squared, but I know r is 5. And if I simplify all this out, -3 quantity squared is +9. And 5 squared is 25. If I move this 9 over to the other side by subtracting, and let's show our work up here, y squared is equal to 25 minus 9, which is 16. Y equals the square root of 16, which is 4. And this is where I say, okay, I know that y is 4, but is it positive or is it negative? I'm going to go back to where I said it was. It's in quadrant 2. In quadrant 2, y is positive, so this is going to be a +4. And from here, all you have to do is just plug into your trig functions. Sine, I know, is y over r. Y is 4, r is 5, so sine of theta, in this case, is 4 over 5. Secant theta, since it doesn't start with a c, it's going to be paired with cosine. So that means it's the reciprocal of cosine, x over r, so it's r over x. R is 5, x is -3. Can I leave that negative in the denominator? Yes, that's fine. If you wanted to bring it out, you could say -5 over 3, that's fine. Cosecant starts with a c, it's not a tangent, so it's paired with sine theta. That means it's the reciprocal of sine, the reciprocal of y over r. It becomes r over y. My r is 5, my y is 4. Cosecant of theta is 5 over 4. Tangent theta, I know as y over x. And let's bring this down. My y is 4, my x is -3, so tangent is -4 over 3. Could you have left it like this? Yes, that's fine. Cotangent of theta, it starts with a c, so it's paired with the last one, tangent, and it also has the word tangent in it, so tangent and cotangent go together because of that. Cotangent is the reciprocal of tangent, x over y. My x is -3, my y is 4. Cotangent of theta is -3 over 4. And this one is pretty much just plugging in. Now, I know some of you were having trouble with is the radius always 1? It is always 1 if we're dealing with the unit circle. But in cases like this, we're not dealing with the unit circle. We don't know what theta is, so most often we will assume that we're not on the unit circle and our radius is what's given to us. And I will continue problems 3 and 4 on a different video.